Hello again, my name is Dr. Bill Johnson. I'd like to welcome you to another edition of Exploring Our Schools. Today, we are going to depart a little bit from what we've traditionally done, which is to have both teachers and kids here. So I guess there's a child in all of us, but today what we're going to talk about is a subject that is near and dear to my heart, and one which I think is a critical mass when we start talking about what it is that we really expect of our kids when they go through our schools and prepare them for the next level of studies. And that is, the centerpiece of that is math. So what I've done is to invite our high school principal, John Murphy. Thank you very much for joining us. And two members of our math department, Mary Coleman and Therese Wang. Thank you very much for joining us. I'm just going to start with kind of a general question, and I know I said it, but is math really a centerpiece of that discussion, or am I just kind of just talking off the top of my head without really knowing? I suspect that the data that we've had over the years and collected, that I can easily support what I said, but I just want to hear from you guys.
There's a strong correlation between a student's math competency when they leave here and their success in post-secondary, as well as preparation for a future career.
Now, competence is an interesting word. I mean, I'm not sure what that means.
Which is a relative term.
Right.
Our definition and our goal is to get students as far into advanced math as humanly possible, depending on what their prior achievement. For many, it's calculus or AP statistics. For some, it's algebra 2 trig. But that being the benchmark, we have a body of evidence, anecdotal as well as statistical, that suggests once students get to those advanced math courses, the probability of them completing college in 4 years, going on to be successful, increases exponentially. Don't ask me to explain exactly why that happens, but it's a tried and true formula.
I know you and I have had that conversation. I've had it many times with your predecessors in this position, and it's very difficult sometimes to ascertain why. But I know that in other discussions that we had even earlier today when we were just talking about it, maybe we need to focus on math really in ways in which we don't always think of it. We think of math as a calculation or a calculation tool. It's really a language, isn't it?
Yeah, it's a way to communicate ideas and things that happen in nature to politics, to business, to sports, using a different language, using mathematics, statistics, calculus, a variety of tools.
And math helps us almost quantify our world. In the sciences, we need our mathematics to explain. We see the things that happen in physics. Objects fall, objects bounce. Why? What happens? How is that quantified? And I think math is the connecting force between so many other areas in our life. And exposing our students to the highest possible level just opens up doors for them of opportunity for any future choice they might make.
You know what's interesting about that is that, we, again, going beyond the numbers themselves and what you were just talking about establishing relationships, you think the kids get that and understand that?
I think over time, as this year I teach physics as well as mathematics, and so I get that opportunity to see them connect what we've done in mathematics to its application in physics. And the light bulb goes on. Like, oh, this makes perfect sense. And then when we solve problems in math, and I can say, we just did this in physics, there's a definite connection between the chemistry and all areas of a science. Mathematics connects. It takes time, though. But unless you're exposed, unless you get the opportunity to play with the mathematics and its connection, you'll never get it.
I see you shaking your head. So,
very often the most interesting applications that they'll see are coming in the later math courses.
Right.
So, you may have a student in an algebra question, when factoring is going to play a significant role in their life, right? But it may not happen until they are doing an optimization problem in calculus where they see that the tools they had learned can be applied to those future ideas.
Can I just be a better student in general? Just by exposing myself to higher level math?
Well, I think so, because it takes work. It takes effort. Very few of us are gifted in that area. So most of us have to work. And it teaches you skills of how to attack a problem you've never seen before, which we have to do in life. Now, mathematics doesn't always have one answer. Well, neither does life. So I think it helps us in a much greater way that there are alternate solutions. There are alternate ways to solve a problem. You know, I have a student who solves something totally differently from someone else. That's acceptable.
Yeah.
That's wonderful. It allows that conversation for how they process to happen. So yeah, I think
It's
it
right
makes
in
you.
line with something that we've discovered, and maybe you could just, both of you, comment on it. And that is that, one of the things that we've discovered is that when kids reach a higher level math, let's say get to calculus, and we go back and take a look at how well they did in college, it doesn't matter what they majored in. It doesn't matter. They don't have to be in the sciences, and they don't have to be in math. They can be in English, they can be in theater. They finish in 4 years, and they do very well. On the other hand, kids who don't quite get there struggle with finishing in 4 years. They very often go to 5 or 6 years. They don't get the same GPAs that their colleagues. So I guess that supports basically what you're saying. What do you think goes on inside? What happens? I mean,
Oh.
does it help me do better understanding Shakespeare? I mean, I don't get it, but I know that there's this connection.
I think, and it's not even necessarily because it's math, but I think most students, as Mary said, when you get to that advanced level, have to learn how to seek help and have to learn that it's okay to go help and get guidance from people. And to us that may seem obvious and natural, but I think that's something a lot of students need to learn. And that lesson, I think, can take them to college where maybe that's part of it. Maybe they've learned to.
See the Times article this morning on, you're advocating soft skills, persistence, perseverance. I'm sick of using the word grit. But that's what this professor advocates this morning in the Times. And a good mathematician would know that we'd have to control for other variables in order to make that determinant, right?
Of course.
We'd have to do, binary regression analysis, some form of linear regression to control for all the other ones. I do think that, though, you have something there, and it may not be understanding differentials, derivatives, but there's something about learning math that has transference, right?
Yep.
Yeah, and I think Teresa's onto that. Students, sometimes for the first time in their academic career, hit a wall of, it didn't come naturally to me. I don't understand it. And so they learn, how to fail sometimes, and that's really an important lesson in life, because we're all going to fail at something. We all failed when we tried to walk, those things. But they also
Not
learn
everybody views it as failure.
Right, but in their mind,
If I
it's
don't
failure.
get it correct,
Correct.
it's another step in the direction
Absolutely.
of finding a new way to solve it.
That's
So-
how we want to approach
Right.
it,
In
but
other
they
words-
often will see it as, I failed.
Okay.
So we have to kind of change their thinking
But
about that.
you have to be careful, because
Yes.
I don't want that to become the mindset.
No, but
Right.
I think often it starts that way, and then
Right.
once they start seeking extra help and discussions of
Right.
how were you thinking about that, how do you need to think about that, what avenues can you take to solve a problem, I think that just helps them as a student in general to say, okay, when I hit that point where I'm confused or I'm lost or I'm stuck,
Yeah, but what
How
you've
do I-
discovered is that whatever the solution that you tried didn't work.
right,
That's a very important piece of information
That's
to have.
as important,
Okay, now let's
especially-
find out what does work.
right, exactly. For science,
It's-
physicists,
Yes.
I remember when the gravitational fields last year, gravitational waves, as soon as they discover something, if that's the end of their discovery, they're disappointed
Yeah.
because they need something else to go after. So yes, you're absolutely right. It's a failure is not failure. It's like Thomas Edison said, I now know 1,000 ways how not to make a light bulb. But in those aberrations of things that happen, you can discover something else. And that's the whole process of learning. I think that's so important.
Edison was one of my heroes, by the way, and it's that line that rumbles around in my brain a lot when I think of how kids should begin to view what it is that they're learning and stop looking at themselves as failures, but in fact, approximations of success rather than in fact taking on the mindset, oh my God, I did something wrong, I'm a failure. So, anyway,
Yeah.
you know what, if we could just change the subject a little bit right now. I think we've pretty much established that it's very important that we get the kids there. The question is then, how do we get them there? How do we open up these doors? I think we've been pretty good at it.
Absolutely.
You know, a lot of the Common Core, I know, Mary, you and I have had lots of discussions about the Common Core, and it appears that, again, what the Common Core has done is locate algebra in 9th grade. Our system does something very different.
Right.
What do you think is the better path to follow?
I think the algebra in 8th grade opens up doors for our students to then be able to reach calculus in high school. If you don't allow that to happen, they won't get to calculus. And I really feel very strongly that their exposure to this type of class is important for them to have for their success later on. It really does seem to prove out, that students who take these higher level classes do better. And if we only have algebra in 9th grade, we've closed that door. And I think that would be a travesty of justice there.
We actually discovered that back in the 1990s, and that's why we began to move. And in 95, we actually made the move to have everybody, we didn't do it right away, but we began to move to have everybody in 8th grade take algebra. So I think that's, and I suspect that you would probably agree, that's one of the paths that we need to continue to emphasize.
I agree, and that is the objective and the aim. However, I don't think anyone at this table would disagree that not everyone learns at the same pace, at the same speed, in the same way. So, to go back to your question, how? Understanding that that's where we start students, and that's where with the aspirational goals. How do you teach math? What systems do we have in place to support that high standard, but also allowing for the differentiation that needs to occur?
Well, I think one of the greatest, since my time here, one of the things I noticed and one of the greatest assets is what we have for the students for whom math doesn't come as easily are the support classes. The fact that, a student can take 1.5 math courses their freshman year for geometry to help give them the added support that they need to be successful. A colleague in another district, who's the chairperson there, asked me, how did you move everyone to algebra? So we were having a discussion. And when I told her, in 8th grade, and when I told her about the support classes, her response was, oh, they won't let me do that. That's going to mean more teachers. That's going to mean more this. And I said, well, that's how they're successful.
Tell her to call me, because I've got to tell you, what's interesting about that is that it doesn't cost you more teachers.
Okay.
And one of the things that we discovered is that what you do is you increase the class size, and you don't have, what you do in the
Right.
tails when you begin to do as she probably does, which is to track kids.
Right.
You end up with very small classes at the lower end and the higher end.
Okay.
When you begin to collapse all of that and focus on support and as a companion to that, then in fact you discover that your staffing is not
That's
changed. It's basically the same.
I also think our 0 period is a huge help to our students. That doesn't exist everywhere. And the fact that students...
In addition to the support.
In addition to the
Yeah.
support, for all students. As well as, honestly, our math teachers are almost never free. So our off periods are really never off periods. We have the Math Resource Center where students come and they seek help. And they often like to be with their teacher, even though there's always another teacher on duty, they seek out their teacher. And there is never anyone who says no.
It's a real compliment to you.
Thank you. And the teachers offer the extra help after school, before school, on their free periods. Anytime they do review sessions. So we work really hard at providing supports for all of our students.
Yeah. Can we just take 1 minute? I saw you just,
Okay.
and talk about support. I mean, people who are watching this don't understand what that means.
Okay, right.
In other words, we live it.
Right.
But not everybody who's watching this actually understands. When you say support, what does that mean?
So if you're a freshman in geometry
Right,
at the school here, you take geometry every day.
right,
Every other day, you can take what we call the support class,
Right.
which is usually a smaller group, no more than typically 12, right? And you reinforce the topics that have recently been covered in class. So it's just one more opportunity in a smaller group setting with a teacher to review the material that is being taught currently in that course.
Right.
Right. It allows the
And it's the
student.
same teachers, by the way, who are teaching everything else.
Right,
Right,
but they
so-
may not have their own teacher, but it's sometimes really nice to hear it from a different perspective, another voice giving an alternate way to solve something. And it gives them more time to practice, to process, because I think sometimes students go home and they don't know how to do a problem. In support class, they're working on the same types of problems, and it's very hands-on. It's not a lecture. It's working on the things that they've done in class, so it allows them to really work.
Don't sell yourself short, because just putting in a lab class doesn't solve anything. It's a great perk, but if you're just reviewing what we did in class today, if I have first period, third period, and eighth period geometry, what's the probability of those three classes learning the same thing? Chances are here that they're on approximately the same page. Why? Because there's a collaborative spirit between the teachers to make sure that there's concurrency of learning going on in the individual geometry classes, which then allows us to offer support classes, so no matter who you had for a teacher, you'll work on completing the square right now. That affords us that luxury. And it's not just a review. You know the students, and I can surgically pick that part of this topic that I know my struggling learners are. So it's more complicated, but also much more surgical than just we're going to throw lab classes at it.
No, the teachers work very hard at collaborating, and they talk about what they're teaching and how they're teaching it constantly. So the lab teachers collaborate, and they're all teaching the subject, so they know. And you're right, we are within, a lesson of each other at all times,
So-
really. So
We're coming down to the end, and I think it's important for us, at least before we close. How successful are we? How many kids do get to calculus? What is the percentage of kids who end up in calculus? What is the percentage of kids who end up in calculus and statistics?
We've been accustomed to over 80% of our students getting to calculus. It fluctuates between 80 to 85%. We're never satisfied.
Okay.
But
Does everybody do that? I mean, is that
Well,
is that a common practice in every high school?
I was going to avoid
Eh?
comparative norms lest our colleagues get upset, but we're breathing rarefied air. This is the barometer of success that very few schools can even aspire toward. So we've taken our success for granted on one level, but it also makes our aspirational goals that we now struggle with, well, calculus and AP statistics, are they the same in terms of experience for the student? These are good problems to have.
Right.
It's
So-
pretty special.
Any last words, right down to the last
This is
few-
only, like all our topics, this is the scratching the tip of the iceberg, that we could go into. It's more to it than this. But math department and the community and the building does a pretty great job of making sure the decisions are our students, not ours, in terms of what they're aspiring toward.
Right.
yeah, it's a unique school that offers a whole lot of opportunity. I've been around to a few different places, and it is unique. And I think we lose sight of that because we're in it, just how unique and special it is.
Well, on that note, I'm going to close. That's a great way to end. So, look, I think it's very important, and I really thank everybody for joining us today. You have to have the aspirations to begin with. We do have the high standards. We granted that. But I think you've heard the commitment that we have, both from an administrative point of view, from an instructional point of view, to provide every single student in this school district the opportunity to succeed at a very high level and get them prepared for the next level of education. So on that note, I'm going to end, and thank you very much for joining us, and we hope to see you next time. Bye now.